Hello, everyone, and thank you for attending today's webinar, Coherent Optics at 400G, 800G, and beyond, sponsored by Cisco, Infinera, and Juniper. Before we begin, I want to cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit them to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask you for your feedback. A survey is already open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading's Principal Analyst, Sterling Perrin. Sterling?
Thank you, Beth, and hello. Welcome, everybody, to today's webinar on Coherent Optics, 400, 800 gig, and beyond. We've got a lot of great content to get through today. I'll of course, be the host and moderator for the session. This one's a little bit different from a lot of our webinars. This is part of a market leader project. So what I'll do here is just kind of explain out what the project involves, and then we'll get into the content of the survey, which is the basis of the project, as well as the webinar, and we'll bring in our speakers. But the focus of this project was on the evolution of coherent DWDM optics. And really, we took it along 2 dimensions. One, the compact pluggable 400 gig optics, the stuff around 400 ZR and ZR Plus and everything that's happening in pluggables. And then we also, for a part of the project, looked at the highest performance optics coming to market at 800 gig and beyond, the trajectory of what is typically viewed as embedded systems. The foundation of the project was a global network operator survey that Heavy Reading conducted in September of this year. We had 81 respondents globally from the survey, all network operators. And this readout here on today's webinar is really the first, kind of the debut of those survey results. So you get a sneak peek of the results themselves. The results will also appear in a analysis white paper that I'll be authoring and working on that right now. That'll come out in November, and everybody on this webinar will have access to that white paper. And so for the content of today, what we're going to do is share some of the highlights from the survey project and discuss and debate with our panelists. The project was sponsored by Infinera, Cisco, and Juniper. They're basically the underwriters of the research. They helped craft the survey. The survey itself was a fully independent light reading, heavy reading survey. No mention of sponsorship, so we get very candid data when we do these projects. So helping me with the readout today will be Tim Duarin, Senior Director of Solutions Marketing with Infinera. He'll be joined by Lorenzo Gionis, Senior Director of Product Management in the Optical Group within Cisco, and Dirk Vandenborn, Director of Systems Engineering with Juniper. So you'll be hearing from them quite a bit as we go through the results. The flow today will probably take about 45 to 50 minutes talking through results in our own analysis, and then really do want to get your questions. It's a hot topic. I can see we've got a pretty sizable audience on for today. So I'd love to get your questions in and take the end of the webinar, the back end, to get through as many of those as we can. In terms of the demographics for the survey, I'll just go through those quickly here. A little bit under 2/3 North America, again, 81 operators, and we conducted this in September. You'll get a copy or have access to a copy of the slides. So I'll just walk through these fairly quickly. The results also skew pretty heavily to large network operators. If you look at $1 billion and more in annual revenue, that was about half of the survey respondents represented by those large operators. For this survey, may not reflect every operator, but for this survey, the ones that gravitated to it reported that their role included both IP and optical responsibilities. Almost 2/3 of the group identifying with that converged type of role in their network. And then let me, before we get into the survey, let me just define the landscape a little bit for the project, for the industry, and then we'll jump into it. But I wanted to just present one slide on coherent optical solutions and sort of a very quick run through of recent history, which may be a refresher for many of you. But the coherent optical transmission really came out as the foundation for long haul 100 gig networks. If we look back to tail end of 2009, moving into 2010, Nortel really pioneered this segment with coherent optics. This was a very significant transition from on-off keying in the past to higher order modulation to both increase capacity as well as distance. It was critical for long haul 100 gig in the beginning. These were embedded systems on line cards, and what we saw over time is some of those were repurposed to fit in the metro, but initially they were really taking a long haul embedded system and applying it to metro, which in many cases didn't quite fit the mark. Moving into pluggables, the CFP form factor, which was really built for 100 gig pluggable, that really opened up a metro market opportunity in coherent. First with the DSP, not part of the optic, but they called it analog coherent optics, and then ultimately and fairly quickly getting that DSP right into the form factor. And then from here, we saw two different trajectories: a metro market more focused on lowering cost per bit and lower power, lower space, and the high-end market, which tended towards embedded, focused on highest performance and spectral efficiency. Where we are today is the focus on 400 gig and beyond. So on the pluggable side, we'll talk a lot about 400 gig ZR, ZR plus optics. I'll walk through the variants there in a second. But also on the high end, we're looking at 100 gig optics and very much an embedded market, very much on the high end, going for highest spectral efficiency on the right. We did a very deliberate blurring in the middle there between metro and long haul on the slide, because what we see is pluggables for any generation moving kind of up market into more long haul domain as technologies mature, and then the embedded moving more down market into metro as those technologies mature, and the battleground is between. And from our discussions, it's a fairly wide battleground, so that's what we show there. My last slide before we jump into some of the discussion and hand it over to our other speakers is just looking at the coherent pluggable options. And we focused here on open, and there's four main groups that we see today really focused on open. And I've arranged them left to right on the slide based on the maturity of the group. What was their start date? Open ROADM being the oldest, focused on high performance 400 gig, Ethernet, and OTN. This was the group that AT&T really championed and put together with growing support over time. 400ZR is the implementation agreement that came out of OIF, focused very much on Ethernet, really driven initially by the hyperscalers like Microsoft, fairly short reach distances. OpenZR Plus, though not technically affiliated with 400ZR, is something that really appeals to the telecom market, driving greater performance still at Ethernet for the ZR types of form factors, which you can see on the bottom includes primarily the QSFP-DD and the OSFP. And then the OpenXR, which is the newest, and this was pioneered by Infinera and their technology introduction, is a higher performance 400 gig pluggable that is point to multi-point. So that is one of the key differences behind OpenXR. Multi-rate going all the way down to a granularity of 25 gig up through 400, and really a standardization push through the OpenXR form. Probably won't talk about that group too much a lot today, but it is one of the four groups that have emerged in open pluggables around 400 gig. We didn't do it, but I could have added non-open types of pluggables, which certainly are emerging as well. So this encapsulates what would be open. With that, let me get into some of the content. And Dirk, I'll bring you in to kick this off. But in terms of defining IP and optical convergence, before we get into a lot of the meat of the topic, we should probably give a bit of a definition. I'll let you kick that off. And I'll push out a reference slide here you may refer to or not as you wish. But a bit of a look at IP and optical integration. Go ahead, Dirk.
Yeah, thanks, Sterling. Yeah, I think this slide here is a very good starting point, right? Some of you that have been around in the industry for years, right, will recognize this slide. It's been in many different shapes and forms. It's been used for a long period of time, 10 plus years. As an industry, we've been talking about packet optical integration, IP optical integration, maybe a little bit more recently. And ultimately, the promise here is to put this additional complexity that we have with WDM transponders, right? Taking that and putting it into the routing and switching infrastructure just to converge everything into a single layer. And that's what you see here. If you look at, let's say, the old model on the top compared to the new model on the bottom, right? We take out the WDM transponders, which are obviously coherent WDM transponders these days, and we move that from the dedicated transport equipment into the routing or switching equipment. Now that's on the physical layer, and that's very important, and I think we will focus most of this webinar on it. You'll see also in the next slide why this is now becoming so relevant in the generation that is now up on us in terms of technology. But before we move to the next two slides, what I also want to point out here is the management piece is actually probably ultimately the most important thing. Because if any of you wants to adopt this technology, right, the big question is, how do you approach management? Do you want to have the optical management and the IP management separate, like we tend to do when these are separate parts, separate domains of our networks? Or do you use this as an opportunity to have converged IP optical management? And how I always see it when I'm in discussion with our customers, we have spent the last decades trying to optimize the transport layer, and we've been very good at doing that, right? We're close to Shannon's limit now. We have also spent decades optimizing our IP layer and have built amazingly dense routing and switching products. But where we've spent very little effort is in between those layers. There's a lot lost in translation between those layers. And I believe the big promise of IP optical integration is really to gain efficiency by integrating between those layers. And we need that integration on the physical layer, and we need it in terms of the management layer. So that would be my intro, Sterling, and what I think is important.
Yeah, just thinking, as you said that on your points about the management layer, there's actually a webinar kind of going concurrently, a bit of overlap with our own today from the Telecom Infra Project TIP on their MUST working group, which is targeting largely what you just said on the management plane. So that group seeing the importance of that as well. It just popped into my head because I realized I had to miss that webinar because I've got this one today, but certainly absolutely relevant. You know, so the next question comes up, and I'll keep you on for this bit, Dirk. But the why now? You know, we were talking. You've been doing at this for over a decade. I've been looking at this for almost 2 decades. There's clearly a momentum. The slide here shows from the survey plans for converging IP and DWDM physically, as you just described, 44% planning for future deployment beyond 2021, 22% saying they're actually working on it now. Quite significant, and certainly compared to past years. So the big question to us in the industry is why now, Dirk?
Yeah, and I think the why now, let's try to answer that with the next slide, right? Because we really we summarize these points. So if you can move there, yeah. So the big thing, right, is, and I mean, this has been true for the last generations of technology. If you move to this complexity that we have in terms of the latest and greatest WDM optics, if you move that into the switching or routing platforms, then you always tended to reduce the maximum system capacity, right? Because the interface, the pluggable interface we were using were always bigger for WDM optics than they were for client optics. In the past, we had embedded WDM optics as line cards compared to CFP or CFP2 interfaces. Then later on, we had, for WDM, we had CFP, CFP2 interfaces, but we had QSFP28 optics for our client interfaces, right? There was always this lag. And now with this generation, with the 400 gig generation, for the first time we catch up, right? We have QSFP-DD optics for the client interfaces as well as for the WDM interfaces. So I can now deploy a routing infrastructure or a switching infrastructure, and I don't sacrifice any of my system capacity while still being able to deploy WDM optics. That's one part of that. The other part, which is very similar, is I do no longer need any dedicated line cards for WDM optics. I can use one line card or a pair of line cards, right, if I want redundancy, and just on a per port basis can decide if I want to use client optics or WDM optics. That is super important because only that way will the true total cost advantage be there, right? If I have to deploy separate line cards for WDM optics, as well as separate line cards for client optics, I will always have to buy double the gear, and that's not going to translate very quickly into significant savings. But these days, there is really a very significant advantage in CapEx because I can just use the same line card for both types of interfaces. Now, and my personal favorite, and I think by far the most important, but maybe I'm a little bit biased there because I come out of the IP space. In the past, we had proprietary WDM interfaces. And I've had so many conversations with customers around that, right? Because if you're working on IP networks, you typically don't understand the word proprietary. In IP, everything's standardized, right? I mean, we all use all kinds of standardized protocols. Now, that's a little bit easier if it's just ones and zeros, right? In the WDM space, it's not only one and zeros. We have a very analog transmission channel, and there's a lot of heavy DSP required. So there were good reasons why we had proprietary WDM interfaces for all these years. But now, the last couple of years, we see this variety of different industry standards that Sterling showed on one of the past slides, right? And particularly 400ZR, ZR+, now gaining enormous traction in the industry. And that is going to be, it's going to be a tsunami effect, right? Once this really becomes mature technology and it's available from a large range of system vendors, I think it will completely change the networks that we're building in our industry. And then finally, and this is also a long road, right? In the past, typically, most of the line systems were closed for one way or the other. The way that optical power levels were managed, how ROADMs were controlled, but also how, for example, the management interfaces, the northbound interfaces, how those worked. And over the last decade, and this has been a slow process and still ongoing, but we've been starting to build open line systems as an industry. And everything starts to become more open. And projects like Open ROADM have very much pioneered this, but there's a wide variety of different industry standards and industry bodies involved. And more we're moving towards this end goal where you can really mix and match different parts of technology, different best of breed parts of technology together. And I think we're getting now to a point where this will really become the mainstream architecture going forward. So I also thought IP optical integration was a good thing 10 years ago, but I think now really all the building blocks are there to make this a mainstream architecture.
All right,
hey, Sterling.
Go ahead, Tim.
Sterling, I was just gonna piggyback on the open line system piece. You know, we've been on this journey of kind of open optical networking with you know, getting to a common set of data models for the pieces that are in the network, getting to a common set of APIs and interfaces, things like the transport API from the OIF or the ONF. You know, in many ways, that separation of transponder from line system, the next logical piece of that or step of that is also then enabling, you know, pluggables as well, because, you know, the transponder is where either it's a card and it's embedded or it's a pluggable. And so we really benefit from that journey of kind of move to open optical and line system versus kind of optical engine separation.
Yeah, and I put up a slide for the audience here, which seems pretty relevant to your comments. And Lorenzo, if you want to comment on this as well, but you know, so the book ended pluggable over open line system. We asked about interoperability priorities. You know, that came in quite strong as a medium priority, but on the higher end, at least for this survey, full interop as an end goal, which would include the mix and match of different suppliers. This is something we're quite interested in. The industry is as well. I guess Tim or Lorenzo, since you're on, any surprises here? Or Tim, I guess since you're on, go ahead, Lorenzo.
Yeah, sorry to interrupt, Sterling, but I think actually, as an industry, we have been a victim a bit of this idea that we need to be special. We need, everybody has the secret recipe for making the system slightly better, and everybody thinks that this difference is very, very significant. But I think it creates an obstacle to the real evolution of the industry. In my opinion, it drives niche product while opening this up, defining a standard, and working on this standard is very important to make sure that we can drive volume, we can drive wider adoption. And I'm not saying that there will never be unicorn. I think everybody will want to keep some secret receipt in the back pocket, but the mainstream should be interoperability and an open line system. And in my mind, I think the definition of the open line system is 360 degrees. And it means not only at the wavelength level, but even making sure that you can ride a wavelength from different vendors or different equipment manufacturer on the same DWDM system without any penalty or without any special tricks. Very, very important to make sure that we drive standardization, we drive healthy competition, and we give customers the possibility to pick and choose depending on where the technology is going. It will always be a leapfrogging game, no matter what. So we should just embrace it and move forward.
Yeah, definitely, right? We need to move more towards the model that's also used in other industries. If you look at the wireless, the radio access network industry, right, where the most highest performance signaling modes are well standardized, right, as part of 3GPP. There's other 5 parts where there's a lot of competition, and that will remain. But interoperability should just be key, also at highest performance. I mean, hopefully we get there.
Yeah, I would just add to the comment. If you kind of look at what's happening industry-wise, there certainly is. What does interoperability mean? Is it the physical layer? Is it from open interfaces? Is it to Lorenzo's comment about multiple vendors over the same line system and the rest? That said, just the one caution I would just say is, performance matters as well. And if you look at kind of behaviors, you'll see a commonality of, yes, maybe there is a interoperable FEC as an example, right? But then you'll also see folks doing something else on top of that. And, the something else is because as a vendor community and for the service providers, how can I get the best value, right? How can I get the best economics and the best value for what I'm doing? And I think it's a plurality of wants that are competing, and the move to commonality, the move to interfaces, it's good, but we gotta, I think, as an industry too, acknowledge that there is some room for innovation as well.
All right.
We don't want to stifle that. Go ahead.
All right. Yeah. With that, it's actually a good segue into the 400 gig pluggables specifically, and just continuing on with open. We actually had a question come in. How do you define open? I think we may have hit on that a little bit just in this past discussion, but with keeping that in mind, Lorenzo, just the overall, maybe at a higher level, the architectural shift to open optical networking. There's a lot of different components to that. I know Cisco's been in this business on the optics side quite a while. Do you want to just kind of give a high-level view, and then we'll get into some of the survey points?
Yes, absolutely, Sterling. I think you had a very good summary in the slide where you showed the different type of standards and MSA that are now applicable to the 400G pluggable optics, and that was specific on the Coherent. So I think we can skip the gray side and the different, interoperability there at the client level or in the non-DWDM layer. For the DWDM or the Coherent, I think the journey that you summarize there is very, very important. And it speaks to what I think, Tim, you were saying before as well. Defining some common ground and assuring interoperability does not prevent somebody to be able to do something else and be able to do better with a bookended solution. As long as there is no barriers for these to happen, be managed. Again, Dirk said it very well before, the way you manage and orchestrate and automate the solution moving forward is absolutely critical. It gotta be done in such a way that it become very, very simple to operate into this multi-domain, multi-vendor type of an environment. And to me, the 400G pluggable optics or the 400G coherent pluggable optics is a great story. It demonstrates the fact that as an industry, if we are getting together either through a standard or even simply through an MSA, I say simply, but believe me, it's not so simple. I fully realize that that's the case. But an MSA is enough to make sure that there is a common agreement and there is for sure interoperability. And then I'm sure everybody of us will be able to add something more, but it could be, as I said before, a bit of a unicorn and is not deviating from the mainstream. The development of the pluggable could be one single pluggable type. What is very, very important, going back to Dirk, is the fact that you can have a single line card which is able to handle both coherent and non-coherent pluggable. Very, very important for us as equipment manufacturer, even more important for customers, because you don't strain capacity. The fact that it's pluggable allows deferrability. You don't need to pay everything up front. You pay as you need it, and you grow into these. Last but not least, and I think this slide says it well, in my opinion, about 2/3 of the people that have responded to this survey is expecting 20% or more TCO saving through the introduction of this new technology. And I don't think it's just the technology per se, meaning that the technology enables a new architecture. Dirk mentioned IP over DWDM. As an industry, we have been talking about this for years. I think it's now time to talk about something more. And there are a couple of terms in the industry: routed optical networking, Google call is Zen, ZR-enable network. At the end of the day, it's the same concept. In my mind, is really leveraging on this new technology, leveraging on this open line system and interoperability to make sure that we change the architecture, we evolve the architecture, and deliver on the expected saving that the customer asks us to deliver.
Yeah, and you covered why I put this slide out, but the question was, I think you've addressed it. I don't know if anyone else wants to comment it, but as moving to open, is the TCO savings, and you can see what's expected here, is that the primary goal of moving to an open architecture? I guess Dirk or Tim, if you want to comment quickly, and then
just
so what this. Tim, go ahead.
Go ahead, Dirk. Yeah, okay. Just in this question, there's really two things in here, right? At least from as I read it, which is the, hey, coherent pluggable optics. Then there's another thing, hop-by-hop routing or hop-by-hop, transport. It would just be interesting to have those kind of broken apart in terms of, in hindsight. It's always easy to come up with the questions, the way you would have asked them in hindsight. But it'd be interesting to dissect that because, hop-by-hop routing has its own aspects to it, which is, at least in theory, I'm not going to have ROADMs in the network, and I'm just going to go router to router. What you find, at least when we've done the analysis and talked to various service providers in that scenario, is you end up needing more transceivers, and you end up with more transceivers in the network, which can have implications the other direction. So this data is interesting. It's just, I guess from my perspective, would have been nice if in hindsight we'd have looked at it from the coherent pluggables, which clearly have some benefits from, I can not have to have a transponder in the network. I can, plug it in various places, and as long as my performance is what I need it to be. But the hop by hop, I would just say, is a separate, almost kind of topic worthy of its own conversation. But, over to you, Dirk. Over to you.
I would largely agree with that, right? But The great thing is there will be a wide range of different architectures that are enabled by using pluggable optics. And there's benefits to all of them, and everybody will make different choices on what works for them, right? What to do in the next few years is also, it's very much around what is your philosophy of how do you want to operate the network. And some things work for others that don't work, that might not work for you, right? But the key thing is really how do I simplify the operation of the network? And then if that means sticking that optic into your router, into your switch, or into a transport shelf, well, I don't think it matters that much, right? But how do you make it as simple as possible to operate that network? And the ones that succeed there, those are the ones that will be successful.
Yeah. But that's exactly the point, right? That's the reason why I think it's important to tie back the pluggable coherent optics and the new network architecture driven like routed optical networking. Because, Tim, I have to disagree with you. I don't think you can achieve the amount of saving that customers expect just by replacing transponders. That, in my mind, and based on our experience, that's simply not possible, mainly because of the fact that the majority of the cost, or a significant portion of the cost, is coming from the OpEx, the way you manage and provision the services, the way you manage the network. And the other point that I honestly disagree with you about is the fact that driving that routed optical networking will drive more DWDM interfaces. Remember, we're not advocating that ROADMs are disappearing overnight and every ROADM becomes a router. ROADM will still have a role in the network, no matter what. The problem is, how do you optimize every pluggable, every wavelength that you put in the network, and how you avoid over-provisioning the capacity that you need? So those are the models that we have done. And in my mind, the reason why I included the open and routed optical networking in the answer is because of the fact that absolutely coherent pluggable are mandatory, have been the step required to enable the industry to make the shift, but it gotta be followed by an architectural change. We cannot continue to do for the next 20 years what we have done for the past 20 years and expect magically to get a different outcome or much better economics.
All right, let me,
I would definitely agree with Lorenzo here, right? We need to get away from this model where we have control planes on both the transport and the IP layer. And there's different ways of doing that, but those new architectures are great, will enable this.
I gotta say this though, but the moment you say that ROADMs are in the network, it's not hop by hop at that point. It's a hybrid, and now we're talking about how do I effectively use ROADMs to express traffic that doesn't need to be terminated at this point and have a transceiver going in and out of it, versus other traffic that does need to go there. So if ROADMs are present, it's by definition, I would argue, not hop by hop, and at that point, it's actually a hybrid, and now we're talking about the mix of hybrid, which is a fine conversation.
Because I think you're confusing the op by op as the service versus the wavelength part, Tim, honestly. We needed to differentiate. You can carve always point-to-point connection in ROADM network. And again, there is no religion against or pro ROADMs. I think that the real question is, how do we optimize the traffic? And that can be done throughout any network. And I know we diverging a bit, so sorry, Sterling, but I think it's an important point.
I know we've got more debate coming on the back end. Let me have the last word as the esteemed analyst. In my view, and we won't debate this one because we need to move, but the data point I put up here, it's almost evenly divided among the architectures. I think this tells me it's very early days, and if we do this in 2 years, and we may get a different view, but you can see almost a third about where they want to stick the pluggables inside the switch router, the IP over DWDM. Is it in a compact purpose-built shelf disag? Is it in the normal system? This could change, but I think this tells us we're quite early, and the debate is fully to be expected at such an early time. So with that, I'm going to have to skip over this bit because we do want to cover the embedded stuff. Tim, let me let you kick off the discussion on embedded, and we have a couple data points to show, and then we'll get into another debate on futures, which is wonderful, and then move to Q&A. Tim, I'll let you carry us through this slide.
Sure. So generic slide meant to show the evolution of coherent optical engines, with time. And so, as you would guess, it's not easy to put numbers on things. But again, we tried to really show collectively orders of magnitude here about how things change with the successive generations of technology, beginning with 100 gig and today at 800 gig as supplied by multiple suppliers. Two things I think I would point out is when you look at today's 800 gig and where we're at, certainly, you can deploy that hundreds of kilometers at the 800 gig or the headline rate. But the two things that really stand out are I can deploy 600 gig at literally thousands of kilometers, and I can deploy 400 gig, I'm going to use a phrase, even though it's an exaggeration here, but almost anywhere. And so, that's benefits from when you think about embedded having lots of programmability and knobs to turn from baud rate to modulation to forward error correction and the rest. That is that kind of any haul application that you can use in submarine, long haul, and metro in some cases. Going forward, we've had the benefit of digital signal processing, process node miniaturization, right? Moore's law, if you want to call it that. Today's solutions are based on 7 nanometer, and looking forward, what you'll see from the vendors, both on this call and others, is where do you want to make the next kind of leap? Is that 5 nanometer, 3 nanometer, 2 nanometer in the future? And all of that in a time where there is no doubt that we've gotten closer to Shannon's limit, and the benefits of spectral efficiency. There's other benefits, but the benefits of spectral efficiency with time are certainly getting harder and smaller as well. You can go to the next slide. Shirley.
Yep. Yeah, and this is to get into just specifically on the 800 gig embedded. We asked, looking at traffic demands going forward, actually over the next 2 years, so a fairly narrow window, how important do you expect embedded 800 gig coherent for your transport network? It's, I look at the critical and say, well, only 10% need it right away. On the other hand, it was a fairly narrow time window. Tim, you want to address whether this was any surprise?
Yeah, I'd also say I don't think there's a lot of subsea related here or ICP, also. So that I'll just say from the demographics of the survey. The other is, we all know, and including the panelists on this call, it's going to be a mix, right? Service providers are going to use a toolbox of solutions to meet their needs. And there are cases where they'll need 800 gig and want to adopt, and there's a list of customer announcements from multiple vendors, including us, out there. But it'll be a mixed utilization of 400 gig to 800 gig over the next several years here, as everybody's looking to refresh and upgrade their network and deal with the capacity demands that continue to be at the 40 to 50% annual growth rate. So, yep. Go ahead, Sterling.
Yep.
Next slide.
Yeah, no, and I not to interrupt you. I just thought this one might be relevant as well in terms of the timelines. And so we had a bit of an extended timeline out to 2025. It was interesting. 800 gig, as you say, is the headline rate. For long haul applications, it'll go much longer distances. For short reach, you could get the 800. This was a fairly even distribution. We aggregated 2 questions to put one data point in front of everybody, but metro and long haul expectations for how much would move to that embedded 800 gig coherent optics. I thought it might skew a bit more heavily towards the long haul subsea, based on that's where the initial interest to be. But again, for you, and then if anyone else wants to chime in, any surprises? Tim, I'll let you take it, and then if any else wants to comment, we'll let you.
Yeah, what I read, if I kind of did the math real quick, assuming I did it right, is that over or right at 50% of the respondents, right, think that somewhere between 21 and 100%, more than 80. Thanks for that one person that said that, or that 1% that said that. But somewhere between the 21 and more percentage of the links or the network will be using 800 gig, and so that's 50%. That's a reasonable number, but yeah, to me the kind of larger metro sticks out, and clearly, look, we're you said it earlier, we're in early days, and it's a convergence of pluggable and embedded technology that will be used, and people are testing and adopting, and it'll just take some time.
Yeah, I think the interesting thing here is, right, the current generation we're building is 400 gig on the routing switching part of the network, and we'll see that transfer to 800 gig in like 2 years from now. That will start, right? So I would think that at that point in time we will see an uptake of really needing actual 800 gig rather than 800 gig to multiplex 2 times 400 gig or 8 times 100 gig. But
right.
That's probably part of the transition.
Yeah, the other is, today we see, 3 by 400 gig client, to 2 by 600 gig, as an example on the line side, or to your point, in shorter distances, 2 400s go into a single 800. But trying to get efficiencies where possible there from a mapping. Yep.
All right, and we are somewhat back on schedule. Tim, any last word before we move on? We did have another slide which I skipped over, but this was another one where kind of an early stage result. Attributes for embedded 800 gig. We had a fair mix there. I know in our early discussions some of these didn't quite hit what you were thinking initially. Any thoughts there, and then we'll move to the final
I can
part.
hit those fast if you just stay focused on the top 3 for just a second. Two things. I think we gave people the opportunity to give the top 3 kind of answers. Again, in my mind, one of the things I was thinking about was maybe rank order, was something we would insist next time, because it just forces that bigger rigidity of response, or more forced response. But the top 3 answers are lower power per bit, minimizing operational costs, which is a good conversation we've been having here, and then also capital costs. So I think if you just kind of stay focused on those, that's not highly inconsistent with your pluggables story too, which is I'd like greater value with each successive generation, and I'd like to, have less power per bit, because there's green aspects of that, there's operational cost aspects of that, and the rest. And so give me more for the same or better, and better value with each successive generation. It's kind of how I interpreted it, Sterling.
All right, excellent. Let's move to the final bit. We do have a lot of questions in, as I suspected, and we definitely wanted to get into the futures. As I said, a lot of what we talked about is new. These are early thoughts, and now we're going beyond new, kind of, out into somewhat deep space. But as vendors, you need to plan for that, and I think there'll be some fairly different views. So beyond, so we have the 400 gig pluggable today, the 800 gig embedded today. What's next for those 2 trajectories? 400 gig pluggable, what happens next? 800 gig data rate, what happens next? I'll let you each comment and then see where we go. But maybe briefly, Lorenzo, if kind of like a 1-minute view of the future, and then we'll do Dirk, and then we'll do Tim.
Sure. Yeah. In my mind, the future is set. So the pluggable will continue to evolve, as well as the embedded will continue to evolve. I said it before, is a leapfrog competition, is a leapfrog game that we have going on here, which I think is healthy. And I think is important to recognize that the optimization parameters that are required for one solution versus the other are slightly different, but both will benefit from the evolution of the technology, right? The team said it. We are, some of us are at 600G per wavelength, some others are pushing 800G. For us, what is really important is continue this evolution. With the Acacia team, we'll launch the 1.2T as the next generation wavelength. Will be a hybrid between an embedded optics and a pluggable, a new concept of a pluggable, because we believe that the pluggable route is absolutely important. But what I want to stress here is the fact that the 400G interoperability pluggable that we now have will evolve to 800G as well moving forward. The QDD 800 has been already defined as an MSA, if nothing else. And so the two evolution to me are set and will continue. And what I think is important is to make sure that we continue fuel the innovation, but we don't push necessarily problem where, a solution looking for a problem. And what I mean with that is going back also to what Tim commented about before, optimization of power, cost, space, and density. We need to keep that in mind and really use the different tools in the toolbox where it makes sense. And the important piece is deploy what is needed and make sure you have room to grow, but don't pump air into wavelengths necessarily.
Excellent. All right, Dirk, I'll let you go next. 1 minute, future 400 gig direction, 800 gig direction.
Sure. So I obviously will focus on the pluggable side of it, right? That is what keeps me busy and keeps Juniper busy. As quite a few might know, there's already a lot of standardization efforts ongoing in the industry to define 800 gig pluggables. The OEF has a project for that is getting really good. It's getting already to the details. So we expect to see those products in the next 2 to 3 years. And then that will match nicely to the next generation of routers and switches that will also have 800 gig ports. So that evolution is already happening. What I think in addition we will see is that there is not going to be a single 400 gig or 800 gig pluggable, right? This market will split up in different directions. Some things focused on very lowest power, some things focused on a better balance between power and performance. So more and more we will see pluggables as an alternative to embedded optics. And particularly on the high volume pieces, we see so many component suppliers now jumping into this, optics suppliers building it. So I think we're looking at a future where WDM optics will roughly be comparable to client optics in their volume and also hopefully in cost point. So it's an exciting future, I would say.
All right, and Tim, giving you the last word on that one, Infinera's view.
Yeah, so we didn't, in this particular webinar, we didn't talk a lot about XR optics and the idea of SubCarrier or digital SubCarrier technology. But as Coherent moves downstream, and you had it in your initial picture, which is Coherent replacing direct detect or moving into the space of direct detect, we think about how to make it economical. One focus is obviously the plug itself, but another focus can be alternative network architecture approach. And so the OpenXR forum, which many service providers have joined, and is a growing list, is working on bringing that technology to life, and that will help us build an alternative network architecture in that coherent access and aggregation kind of space where we can reduce the number of transceivers. We can have the ability to assign and scale the 25 to 50 to 100 gig increments. And so, I think the future is 400 gig pluggable, yes. Alternative architectures, yes. Smaller 100 gig to replace what we're doing in direct detect. And then also that you'll see that move upscale in 800 gig from a pluggable simply by doubling the number of subcarriers, which we didn't have time for a question, but it'll be in your final report, which was, the top benefit people liked from subcarrier technology in OpenXR forum was I could go from 400 to 800 gig without having to replace the downstream optic. And then in 800 gig embedded, definitely there's the future is use the next gen of DSP 5 or 3 nanometer and looking at, does that move to 1.2 or 1.6 terabit, and does that somewhere in the 140, 150 gigabaud kind of range.
Yeah, excellent.
I'll pause there.
I guess I'm wondering, and maybe like a 1 minute, because we do have a good number of questions in, but for the group, is there an end to this data rate, climbing up, the gigabaud rates, the 800 to 1.2, 1.6 with Shannon limit? Where's the wall? Dirk, I guess I'll let you give a view, and then if anyone disagrees, and then we'll move to Q&A. It's a quick one. I probably shouldn't have opened up the can of worms, but I just got really curious about what's the end game.
Sure. Ultimately, it's cost per bit, right? I mean, how can we, for a given capacity, provide the lowest cost solution? And that, in the end, that doesn't really matter if it's a single wavelength or 2 wavelengths or 4 wavelengths, right? Traditionally, going back a few generations, single wavelength was ultimately always the lowest cost option. But it might change, right? In the next generations, maybe integrating 2 wavelengths or 4 wavelengths in a tight way might be the lower cost option versus going to ever higher baud rates. And that's what I would also see. I think ultimately, we'll see 120, 130, maybe 140 gigabaud. But beyond that, wow, you really need some very exotic technologies.
Mm-hmm. Anybody disagree with that comment? If not, we'll go right to Q&A.
I slightly disagree with the fact that the technology will reach a limit. I think we have been through this multiple times, and we always found a way to beat what was perceived to be a limit. Granted, I'm convinced a Shannon limit exists, but never say never. I don't think that even the baud rate, when we were starting with Coherent, it seemed like, oh my God, 32 gigabaud is extremely big. And look at where we are. We're looking at 120, 150 gigabaud, and that's just what we have in line of sight for. What I think is very important to realize is the fact that there will be probably a practical limit of how big of a wavelength, how big of a signal you wanted to put on the system, because at that point, if you're consuming all of the capacity on that single signal, it is probably too big to chew for a lot of the application. We already see now with 400G, there are, I think, 2 extremes, right? The content provider, never enough. The majority of the customers are using or looking at 400G, but the definition of 400G will probably be too big for many of them. And what I think we need to do is really offer alternative solution to make sure that we can optimize the capacity for what is needed. And that's again, going back to my argument earlier, but that's the point where we can drive better cost, better OpEx, better CapEx overall as an industry.
All right, excellent. With that, let's jump into the Q&A and maybe go a couple minutes over, because we do have a lot of questions in. But I know our presenters will be happy to follow up one-on-one, but with individually post-show, but I wanted to get a couple in before we close out. So this one patiently asked about an hour ago, so we'll get this one first. Dirk, it was related to your portion when you were speaking early on. How do you compare IP over OTN over DWDM with IP over DWDM in terms of protection? And I think the meat of the question is, does the OTN layer go away moving forward? I think that's an interesting one. Dirk, what's Juniper's view?
Yeah, definitely, right. So we see OTN has its benefits in terms of framing, right, as part of WDM interfaces. We don't think it has a role for switching or protection in the network. So definitely IP over WDM, right? There will be deployments where you have pure OTN traffic because you have non-packet interfaces, non-Ethernet interfaces, but those are getting less over time, right? So what we see is you need a single control plane in the network, and that's with the maturity and the focus of the industry around Ethernet and around IP, that preferably is on the IP layer. That will give you the lowest cost per bit, the lowest cost of operating your network, and it allows you to benefit from all of these innovations on the control lane that have been ongoing for the last few years.
All right, excellent. Let me go to the next question because I don't want to get into any more debates, although I love it. We just ran out of time. There was a question specific to your comments, Lorenzo, so let me give you a chance to clarify here. You mentioned somewhat briefly a hybrid between pluggable and embedded for the future, and I agree it was somewhat confusing. The 1.2 terabits, this person just wants to understand, what are you talking about, a hybrid between a pluggable and an embedded?
What I mean is the fact that there is room for both the applications. There is not a single answer. It is not one or the other. What I mean is the network architecture needs to be flexible to deal with both the approaches. It is not a religious approach, everything got to be a coherent pluggable, or everything got to be a specify embedded transponder-based solution. And that goes back to my comment earlier about an open system with a very solid management and automation. If we as an industry can deliver something like this, we can enable customers to move at their own pace and show the advantages of the different technology, because I'm truly convinced about the fact that there is not a single solution. There are optimization depending on the customer preferences, the customer history, the situation with the type of equipment that they have in the field with ROADM, fixed ROADM, flex spectrum ROADM, and those type of nuances. And so there's not one single solution. There got to be a toolbox, but what really enables all of these is the flexibility coming in from an open architecture and a full suite of automation and management solution that deals with all of the different nuances.
All right. Thank you for that. That clarifies for me as well. Tim, there was a question related actually to this slide, if I can push it out and then find the question. Now I've lost the question. Hold on. It had to do with the DSP, and there it is. Okay, yeah. The DSP geometry, is that the main limitation for higher capacity? It sort of implies it here. Maybe you answer, and if anyone disagrees, we'll let them chime in.
Yeah, part of the reason we left the DSP geometry, or node geometries on here was just, your optical engines are based on, two key, we'll just call it two key building blocks, right? It's the digital signal processing back end, and it's the analog optics front end, however you choose to do that on the analog optics side, meaning like photonic integration or whatever. So the DSP technology gives you the ability to, and the smaller geometries to, reduce space and power, or do more. As just an example, our current DSP we use in the 800 gig i6 engine has 5 billion transistors, the equivalent of that, versus what used to be in what is in the past generation, our ICE4 has 1.5 billion transistors. That gives you more things you can do, and yet your power curve coming down. So part of the reason we never had pluggables before, well, we did have pluggables before, but part of the reason we're at the pace we are with 400 gig pluggables is in part because of the benefits of silicon geometry as tied to this. So it is not the only benefit. It's not the only thing, because the algorithms you develop, like probabilistic constellation shaping and Nyquist subcarrier technology and all of that go to the performance aspect for sure, but the underlying DSP silicon geometry reduction has its net benefits in terms of power and density. And that's why it was just shown. Yep.
Excellent. I know we're at the hour. Let me ask, I think, just two more questions, and then we'll close out for anyone in the audience that wants to continue to tune in, but maybe go put 2 or 3 minutes over. This OTN thing came back again with another question. FlexZ seems to be trying to replace OTN in several applications. I know I let Dirk weigh in on the OTN. I'm curious, does anybody see a role as we move to 400 gig and 800 gig in continuing with an OTN layer? We know Lorenzo's view. I guess Dirk, if and it could be a quick answer, but does OTN continue? And then Tim as well. But Dirk, I suspect you agree with Lorenzo.
I mean, there are some applications for OTN, right? But in general, it will be diminished. And you see also, for example, the 400ZR standard from the OEF, right, which does not use OTN framing anymore. It's a native Ethernet standard. And then briefly to the FlexZ part, I was personally involved in some of the early parts of FlexZ. I love it as a standard. Unfortunately, it was not adopted by the major switching ASICs built in this industry. And that makes it just difficult as a future technology.
Interesting. Tim, differing views or?
No, OTN is certainly there. We have non-IP traffic, and other things like, fiber channel, whatever else. But it certainly feels like, less over time, right? Less important over time. But you got the existing networks you got to deal with. And so if you want flexibility in the toolbox, then, probably there for some time, depending, right? The 400 gig ZR is very specific, right? About it's really pointed at that DCI point-to-point non-ROADM cascade application. Fine, right? I mean, it's fine. It's got a purpose. But if you want something that's more of a multi-hauled approach, I guess I'll just call it, or more flexible, then for now, OTN's there, but over time it does feel diminishing.
Okay, I think I would agree with that. I was going to ask another question. There's a couple of things on brownfield, but they're great questions, but there's no way we're going to cover that without less than 10 minutes. So we'll close out here. I know our presenters will be happy to follow up post-show on some of these great questions. Really appreciate the audience for tuning in. We had great numbers, great engagement, and thank you to our partners on this webinar, Infinera, Juniper and Cisco, and to Tim, Dirk, and Lorenzo for all your help in putting this project together. Thanks, everyone. Enjoy the rest of the day.
Thank you. Thanks, Sterling.
Thanks, everybody.
Thanks, everyone.
Thanks.